Hello and welcome to the Artec Ray and Geomagic Control X collaboration. Today we will be doing a basic wear analysis inspection using LiDAR data that has been acquired by the Artec Ray. So what we'll have is the measured data and we'll have a reference set CAD inside of Control X. As you can see on the screen now, we are in Control X and we are prompted with a few user profiles. So operator, this is set up more for acquiring data. Since you're doing this in Artec Studio, that will be acquired in that specific software. Going on to basic, this is where you can set up a specific workflow. So if you have something that you do day in and day out, you can minimize some of the tools that are in here. And then for expert, this is a complete set of tools. So let's go ahead and hit expert. So now you can see here we have already imported the reference data CAD, and then the blue data is the measured data we acquired with the Artec Ray. So what we want to do now is we want to bring the measured data to the reference data, and we can do that really quickly by using something called our initial alignment. So this will roughly align the measured data to the nominal data. We'll let that run. Right, and so now we have a rough alignment. So we can use multiple alignments here for something like this for wear analysis. What I would typically do is a best fit alignment. So let's run our best fit alignment. Let's make sure we have 25 max iteration count. And let's say there is some more important data that we want to fit to. We could always use selected only data. So if I came in and I selected a few of these CAD walls and maybe some of these important areas that we're actually looking at, we can do it that way. But for today, we are going to do an overall best fit alignment. Right, and so now we're in the best fit condition. Right off the bat after this, I would typically do a 3D compare. What this will do is it will have a maximum and minimum distance with the specified tolerance that is a pass or fail. For this, I'm going to say along normal. And I'm actually let this one go into the next tool there, but I'm going to go next stage. And now you'll see the color bar change where for something with this big of tolerance, I want to change this to, let's say, 20 mil plus or minus, and then I'm going to give a 5 mil tolerance there. So now you can see a little bit more of a realistic tolerance table on that. What also I'd like to do here too is we can turn on these over and under tolerances. So what this does is this is the highest over tolerance in the whole part, and this is the lowest in the whole part as well. We can also change these to a higher number. Let's go 3. And at this point, I just really wanted to get an overall idea of what's going on in the inspection. And from what it looks like, right, is we have most of it coming from the backside here, where this is not as important. The important parts are the areas that will see the most wear, and this is what typically we see with the LiDAR scan data. If you're doing a wear inspection, is some of these areas that would take the most abuse. We want to see this before it actually happens, so we can, maybe adjust what we need to do, or tackle the problem before it takes the tool off the production. So let's say okay on this. And typically what I would do at this point is I would find an angle that represents what I want to display, and I would then click on 3D Compare 1, And over here down on the bottom, we have reassign viewpoint. And at this point there, this is what's going to be populated into the report at the end. So at that specific point now, what I would want to do is I want to kind of show these areas that are low in the report so we can keep an eye on them. So what I'm going to do here is actually hide this 3D compare one along with the annotations, right? And I'm going to actually, so I'm going to turn it on, but hide the annotations. And I'm going to zoom in on this specific area, and I'm going to open up the comparison point tool. And just like before, I want to change my max and min range to 20 mils. And that will change there. And then my specific tolerance to 5, right? And at this point, I could actually do maybe more of a method of an ordered pick with a linear pattern or a circular pattern. But for this, I really only need to come in and zoom and just start picking areas manually. This is typically what you would do too with a laser tracker. You would just have the CAD data, you would have it aligned to the world, and then you would come start touching off on this area. So this, you can see here, makes this a lot faster of a process by being able just to scan this with your Artec ray and then do a quick alignment. And now we have, really accurate data of what's happening on this part. I'm actually going to change this to snapped because I want to orient this in a fashion that best depicts what's going on. So I'm going to actually say OK here, accept that, right? And now I'm going to kind of just move this around to help the reporting style show what's best going on. And then just like before, I'm going to go and click CMP1, comparison point 1, and say reassign viewpoint. And now you can see our view in the actual scene is now going to be populated along with our table. So I could actually assign these to, I could give this a different name for the demonstration. We're just going to leave these, but if I wanted to call this the right side of the loader, I could do that, and right one, so on. So that gives you a good idea what we're doing there. The next thing I would do here is I would typically do a 3D compare of just selected areas. So let's turn off the comparison points. Let's turn off the 3D compare. And we're going to come into 3D compare again. And just like before, I'm going to use a long normal and say, but this time I'm going to say use selected data only, right? And this kind of gets a little bit more manual here. So I have to come in to this area and start picking these CAD faces that are important to me in our wear analysis. And then also this is a typical area that would also wear out quicker than most of the other areas on this loader bucket. So really quickly I can just right click, move around, and then left mouse button to acquire what I want to show in that comparison. So this is a good way to show, you don't need a full comparison of the actual part. You can actually use just selected areas there, right? And that looks good for now. So we're going to do the same thing as before and say next stage. And just like before, again, I'm going to change this to 20 plus or minus as my max and min. And I'm going to go to 5 mils for this, right? And just like before too, but this time I might go to 5 over and under, 5 over and under. And I would like to also point out is I can actually come in here in this 3D compare tool and manually pick as well. So this is a very fast and easy way to show, hey guys, we need to show that this area here is well under our tolerance, so we would have to address this as soon as possible. Right, so I'm going to accept this, and just like before, I can orient the part in a way that best depicts what's going on here. Maybe I would use the snap tool on this one and go into 3D compare and say next stage. And this is what's going to then show into the report. I can also say I want to add a custom view, right? And I can come to this area and say I want to report this in, by highlighting this, I want to report that into the final report. Now that we have done our typical wear analysis using comparison tools, we could go over to the back side of this part and maybe do a more of a fitting with dimensional stuff. So if I say hide my comparison tools, right, I can then turn my dimensional tab on, and I'm going to use the smart dimension. So what would be important here would be maybe the distance between these two fitting planes, and then also these cylinders. So really quickly I can turn on the smart dimension tool and start using the reference data to build these nominal linear dimensions. So without exiting the tool, I can come over to the middle and start using this as well. And you can see how quick that smart dimension tool is. I don't have to exit the tool to keep developing dimensions, right? And you see I'm in a linear dimension. Now I'm really quickly gonna switch over to a radial dimension, and I don't even have to exit that smart dimension tool. As you can see there, I will click on the cylinder and click outside of the project. Say okay. So if I ever have that, that must mean that I don't have acquired data in that area, which I don't. So that's not gonna give us a load. So those cylinders there, we didn't actually have required data, but we have enough data to do a linear dimension, as you can see. At this point, I would say okay, and then I could right click on one of these and say I want to actually have a more detailed detailed description of what's going on there. So this is another kind of different style of inspection for a part like this using that LiDAR data, as we can see here. So at this point, what I would do is I would click on my GD&T and group 1, and I would say next stage. And as you can see, this is what will be populated in the final report. And I can either go into tools, or just from right here in the dimensions tab, I can say generate a report, and you'll see this window pop up. What I want to do now is I don't need the initial alignment inside of the final report, so I'm going to push that back over to the side, and I might put custom 1 above group 1 of that dimensional analysis, and I'm going to say okay. And now you'll see how quick this report is generated. I can use this data to then analyze for our next inspection to see when we should start, really focusing on when this area is going to fail, and have a better plan of attack. And this is what we typically see with a lot of LiDAR data, is this wear analysis inspection. So I want to thank you for the day. Our collaboration with Artec and Geomagic Control X is a very powerful way to help guide decisions made by a company. So thank you for your time. Okay, goodbye.